In this video, we'll be demonstrating the calibration procedures of a 6920 version 2 YSI Sonde unit. So the unit that you get from the shelf should be in this working order. It's stored in this procedure. So the battery cover is off, indicating that there's no batteries inside the Sonde. And it should have a water cap in if there's a sensor that requires water so it stays wet. So in this unit was stored in this water cap. So today we're going to be calibrating unit B6. The first step in calibration is filling out the calibration worksheet. So this is the form. I filled it out for today's date in this form with the days, month, years, the time, and military units. The technician today, Terry Palmer, is going to be calibrating this unit for me. The serial number of the unit and the model type. So this is unit B6. Also, we have the barometric pressure, so I'll demonstrate to you how to locate the barometric pressure to give a lab reading. To verify pressure of the Sonde unit, navigate the computer to Weather Underground and go to Corpus Christi Naval Air Station site, which is the nearest to A&M Corpus. Right now the pressure is 29.96 inches. Then you'll need to convert that into millimeters of mercury. So using this website, I'm able to convert it from inches of mercury to millimeters of mercury. So right now the pressure is 760.9, and write that down on the calibration sheet. Now we're going to be putting the batteries in the unit and hooking up to the computer. So the first thing you do is you remove the battery cover and you place 8 AA's into the unit. There's a molded notch on the top of the battery cover that shows you where to put the batteries in and what direction. So in this notch it has the positive on the bottom and negative on the top. So when you put the batteries in, make sure to have that correct. Otherwise the unit will malfunction and the batteries could explode when it's being deployed. Screw the cap together, but don't tighten it with any kind of tool. Just finger tight. Remove the top cap and then connect it to the computer cable. The computer cable doesn't need to be screwed in, it just will fit flush, and you'll feel a syncing click, and it's now connected. Double click the EcoWatch program, and in this program you can either click this button that looks like a little dynamite, or you could go to COM Sonde, and then there will be a window that comes up that says what COM port to use, and it should be selected COM 4. Now this should come up with the Sonde menu. This is actually from the Sonde itself. The first thing we're going to do is we're going to check the date and time, and we're going to check the battery status to write that down on our calibration sheet. So what we're going to do is we're going to hit 5 for system, and then we're going to go to date and time. And the first thing I want to find out is that it's in year, month, day form, and that's selected already with 3. Right now the date is correct. It says 2016 May 20th, but in order to change it you would just hit 5 and you could change that. To the time, what you can do is you double click the time icon on the bottom of this computer, and that brings up this time window, and this computer actually synchronizes its time to an internet time, so it is the correct date and time. So what I can do is I can move this window to the side, and then I can type in the exact date and time. So I'm going to move it right here. Okay, so now I have the time displayed right here. So I'm going to click time 6, and the time right now is 11:49 and 54. So now I have the precise date and time calibrated, so I can move back up to the main menu. So now we're going to calibrate depth on the Sonde. So I'm going to go to 2 for calibrate, and it's going to be under pressure, number 2. And enter depth in meters. Right now it's in the air, so the depth is 0. Push enter, and it's going to come up with the window that it's going to stabilize. And right now the depth is 0.06. We're going to write that value down on our calibration sheet for the pre, and I'm going to push enter. So now that calibrates it. This is the post, 0.0. So I push enter, and now that's calibrated. So let's move to the calibration sheet, For the row that says depth, you write down the temperature that was on the probe, which was 21.5. Write down the value of the standard. The value is 0 because we're in the air, we have no depth. The initial reading was what it first came up on the display, and it was 0.06, so write down 0.06. And the calibrated 2, that's after you push enter, and that's what the depth sensor now reads, which is 0. So now this is completed, so now we have completed the depth calibration for the Sonde unit. Alright, so we're ready to calibrate the conductivity sensor. And on this YSI Sonde, this is what the conductivity sensors look like. It's a very small sensor with a metallic probe that comes off the end. There's actually 2 holes on one side, so there's a bit of wire on one side and the other side, and so when it's in the water, it measures the electrical potential between. So the first thing you do is you locate these 2 bottles with conductivity rinse and conductivity buffer. This is how you should find them in the lab, is that you should have the leftover rinse, this is from last time, and the buffer should be empty. So if you find it where there's buffer liquid in the buffer, you should pour the rinse out and put the buffer in the rinse. Okay, so now what we're going to do is we're going to fill the buffer up. So now we pour the liquid of the conductivity buffer inside the jar. Make sure that there is enough in order to completely cover the sensor. And we also take note to make sure that we have our units correct. So this standard is 50, and that's what we're going to be writing down on the sheet. So now we take our unit and remove the cap. We take our pressurized air to blow off whatever water or liquid that's on the sensors to clean them with. Now we place the sensor heads in the conductivity rinse, and we need to verify and check that we actually have enough standard, enough to fill the sensor. Okay, so we verified that we do have enough, so now it's rinsed. Now place inside the buffer solution, which is what we're going to be calibrating against. Again, to verify that we actually have enough solution, which we do. And place the unit upside down into the Sonde holder. This is where the cable goes, so that way it's protected. And so the sensor is upside down in the solution so that all the solution will cover the entire sensor of the conductivity sensor, which is this little one right here. Alright, now that we're back on the computer, then we go to conductivity from the calibration menu. And we're going to do SPCon, which is number 1. And enter the SPCon, that's our calibration value, which is, it's already 50, but it is 50. So we can either hit enter or we just push 50 and enter. So again, it's going to give us a reading of the Sonde. This is the pre-reading, and so right now the conductivity is 50.31 and the temperature is 22.07. Both of those we write down on our calibration sheet. Now we push enter. Now we write down the post value, which is 50.00 on the calibration sheet. And we have now calibrated our conductivity. Okay, so now back on our sheet to verify for specific conductance. This is the temperature of what we found on the Sonde. This is the value of our standard, which is 50. The reading was 50.32, and we calibrated to 50. Now there's a couple extra things we need to do. One is called the zero check, which we'll do right now, and we need to clean up our standards. So here we have our rinse bottle, and the rinse bottle needs to get poured into the sink. And remove the Sonde from the stand. And open the buffer container. Now this buffer we will save for the next time's rinse. So we pour back. we place the cap of the conductivity rinse on the bottle, and now we store back in the top of the shelf. Okay. Now the Sonde unit is dirty because it's been in conductivity, so we need to rinse it off with our DI water. So we rinse with DI, and just as we did before, we blow it with the compressed air. And rinse and clean the conductivity jar and place above to dry. So we get our compressed air and we fully clean the sensor again. And wipe dry with the Chemtech wipe. Now we're ready to do the zero check on the conductivity sensor. So for this, we go back to the computer with the sensor in the air. For the zero check, we do not do calibrate. We actually go back to run. So I'm going to push 0, 0, and then I'm going to go run and discrete sample. Start sampling. This is to check the sensor that's in the air, so there should be no electrical impulse moving through the sensor, so it should read 0, which is right here, 0.00. So now we can put a check mark on that part of the calibration sheet that we did check the 0 standard. So right now we're going to calibrate the DO sensor. That's this big sensor right here. This one has happened to be wrapped in copper. That's just for anti-fouling. This is an optical sensor, which is in the largest port of this unit, and it has a wiper with a little bit of cloth that when the sensor turns on, it runs around in a circle and wipes the top clean. So there's actually 3 methods we use to calibrate DO in this lab. The first method that we use in the field is a wet rag with the cover protector. The second method that we're going to demonstrate today is water in a storage cup. And the third method is using an air bubbler in a bucket of water. But right now we're going to be mainly demonstrating to use the cover method and the field method. So for the cover method is you make sure there's just a tiny amount of water in the bucket. The sensor does not have to sit in the water. We just want to make sure that it is wet. In this method, the cap is meant to be vented off the top, and the sensor is not supposed to be in the water itself, but the sensor was previously wet. Alright, so we're back in our Sonde menu on the computer. So push calibrate, number 2. And now we're going to calibrate dissolved oxygen, 3. And now we're going to use percent DO saturated, which is number 1. And a 1-point calibration. So the barometric pressure that the unit is reading is 761. We actually write down the pressure that we listed on before on the sheet, which is 760.9. Push enter. So now it's going to give us an initial reading, which we'll write down on a calibration sheet. So the initial reading is 100.3. And we push enter. And now it is calibrated to 100.1. The temperature, now we do have to write it down, is 22.22. So now we have calibrated our DO sensor. So now we're going to demonstrate the field method, which we'll be using out on the boat at the sample. So if your unit is with the protector cover cap and you're ready to deploy the unit, you get a rag wet and then you just wrap around the protective cover and you calibrate using that method. So now we're ready to calibrate the pH probe. On this unit, this is a very long pH probe. It's a double length probe, but it has a small, looks like a little light bulb in one end. This one is wrapped in copper as well for anti-fouling. For another example of a pH probe, this is a standard length pH probe, which again comes out of the smaller port with the light bulb at the end. So this is what they look like right here. They're optical, but they don't fit in the large port. They fit into the smaller ports of these YSI units. So for pH calibration, we're going to be doing a two-way calibration using pH 7 and pH 10. So in order to have this, we have a buffer and a rinse for 7 and 10. And as we located these off of the shelf, they were improperly put up. So the buffer was used previously and there was no rinse. So you need to pour the buffer into the rinse. So we're going to be filling up our buffer containers. So this is the pH 7 standard, and with pH, the standard actually changes with temperature, and so there is a temperature table right here that shows you what the value of the standard is depending on what the temperature is out in the air. So you'll need that for calibration. So here we're doing just a two-way calibration, but if you're using a three-way calibration, we do have pH 4, which would require 2 more cups for a buffer and a rinse. Now that we have the containers ready, we're going to go ahead and start the calibration procedure. So we place the sensor head unit in the pH 7 rinse. Flip upside down to make sure that the sensor was completely rinsed with the standard. And now placed into the buffer solution. So now we make sure that the tight was screwed in tightly, but this sensor we do not put upside down. So we leave right side up, so that way that the solution can fully cover the salinity sensor, which is also the temperature sensor, because we need that for calibration purposes. And we set straight down on the table, and we move to the computer. So before calibrating the pH sensor, we need to actually discover what the temperature is of the solution. So we go to Run, Discrete Sample, and start sampling. So right now the temperature is 21.7. We write that down on the calibration sheet. So now we're ready to calibrate the pH sensor finally. So I hit 2 for calibrate and pH. We're going to need a 2-point calibration. Now the first pH, using the table that was on the box of the pH standard, is 7.02. Now the initial reading for pH is 7.06. You write that down on our calibration sheet. And we push enter. And it calibrated to 7.02. And we push enter again. And it calibrated to 7.02. Now we need to write down the pH millivolts. That's negative 5.4 on the calibration sheet. So we push enter. Now it's ready for the second pH value. So now we go back to the unit. We remove the 7 buffer. Now we rinse and clean the unit with DI water. And compressed air. And if required, a Chemtech wipe. So now we place the sensor head in the pH 10 rinse. Screw the cap down so it doesn't leak on the table. Thoroughly rinse the sensor head. Unscrew and place in the pH 10 buffer. Now on the computer, for the second pH, using the table from the standard, we type 10.04. We wait for the sensor to stabilize, and the initial reading was 10.06. We write that down on the calibration sheet. We push enter, and we write down the post calibration as 10.04 with millivolts negative 181.8. So back on our calibration sheet to verify, if we had done a three-way, we would have had a value for pH slope 4, but we're doing a two-way, which is the 10 and the 7. So these values are all filled out. Now we have to do a standard check. So our standard we're going to use is a pH 6. So we're going to move over here again. So this is our standard check. This is a pH 6, and again it has a table showing what the value is depending on which temperature that the liquid is at. So we're going to pour this into a separate cup. Alright, so now we remove the sensor from the pH 10, and we rinse and clean with the DI water and the air, just as we did previously. So now with the sensor clean, we can place into the calibration fluid. This is the pH check 6. Now we need to verify that the sensor itself is actually under the water, and we find that it is not in the solution, so we need to add more. Okay, looks like it's now underneath the solution. So now that we know that it's under the sensor, we're going to rinse with the solution. Since we don't have an extra cup for this, we're using the same cup for the rinse and the buffer, with the same procedures apply. Use the rinse. Now that rinse has been used and is thrown away, and more solution is poured in, and this is now going to be the true buffer. Again, verify we have enough solution for it to sit, the sensor to sit in the solution, which we do. Now, just as we did for the zero check for conductivity, we go back to the computer, we do a discrete run, and we verify that the sensor is at value of 6. Typically, you only do this for a three-way calibration, but we did it for this video just for demonstration purposes. So now that we're done with the 6.0 pH check, we clean the unit just like we did previously with DI water, and we clean up our buffer and rinse containers, again by pouring the rinse out into the sink and pouring the buffers into the rinse containers and closing the caps and storing back on the shelf for next time. Now our calibration procedure of this sonde is complete. So the way to store this unit is you put just plain tap water into the storage jar, because the sensors have to stay wet. You place the sonde into the screw into the cup. Disconnect from the computer and place the cap that goes to the corresponding sonde back on. So now we've calibrated this unit and are ready to store into the shelf. This unit is ready for discrete measurements. And in the next video, we'll talk about the deployment procedures to deploy this in the field.